equations and solving them and rewriting them. But most of this should be review, so I hope that it's not too, like, mind-boggling. I'm not going to read this whole, like, paragraph to you at the top because you can read that on your own. Basically, you have exponential growth, you have exponential decay. This is something that we've been looking at since Math 1, right? So we know this is a thing. I'm not going to talk about it a whole lot. If your A value is bigger than 1, it's growth. If it's a fraction less than 1 or a decimal, then it's going to be decay. Again, this is all stuff that we know from Math 1, right? They're supposed to pass through the same y-intercept, and that's 0, 1, because anything to the 0 power is what? 1, right? So you're supposed to have that y-intercept of 0, 1. So if you're thinking like your parent functions for exponential functions, that's a good point that's always going to be on there. So then when it starts shifting around, that point is going to change. So that's like a reference point if you need one. So that's what this stuff is saying here. Your domain is going to be all reals, and your range has got to be greater than 0. Is that okay? Yes. But you need to know how to do that because it's really not hard. So we're going to graph these guys here. So for the first one, we've got 2 to the x. So to do that, make a table or just like plug stuff in. So if we plug in 0, what is 2 to the 0? 1. Anything to the 0 power gives you what? 1. Then 2 to the first power, what are you going to get? 2. Anything to the first power is itself, right? And then if we do 2 squared, what do you get? 4. So it's getting really big, really fast. That's a characteristic of an exponential function, yes? So then we're going to start plugging in negative numbers, so what's going to happen?
It's going to get small.
It's going to get super, super small. Is it ever going to go past 0? No, because what do negative exponents do? They like flip it, right? So you're going to have like 1 over 2, then 1 over 4, then 1 over 8, then 1 over 16, right? So it's getting super, super, super small fractions, but it's never going to go negative, right? Okay, so we would have 1/2 and then 1/4, and it will keep getting smaller, and you'll level out. And what do you think is happening here, since it's going to get super, super close but never touch? You got it. Is this all stuff we know?
Absolutely not.
Oh, well, y'all are smart cookies then. You're smart cookies. You figured it out. I know it's like super hot in here, but it was too loud. I couldn't. I'm sweating. It's fine. It is. It is. Yeah, it's fine. All right, so for number 2, we've got 1/2 to the x. So how is our graph going to be different this time? Instead of growth, it will be decay, right? So do you think that these graphs are going to be similar at all?
Yeah.
How?
Flip.
Just flip it, right? So if we have like 1/2 to the 0 power, what do you get? Anything to the 0 power, what do you get? 1 every single time, yeah? So then 1/2 to the first power, what do you get? 1/2. 1/2 squared, what are you going to get? 1/2 times 1/2. 1/4. If you do 1/2 cubed, what's that going to be?
1/8.
1/8. So it's getting super small on this side now, so what do you think is going to happen on the other side? It's going to get big. So when we plug in -1, that's going to flip your fraction, so it's really just 2 to the first power, so what do you get? 2. Then when you plug in -2, again, it's flipping your fraction because that's negative, so it's going to be like 2 squared, which gives you 4. And there's the graph. We'll kind of stop it there so we don't have room to go to the rest. And we'll leave it at that. That okay? Questions? All right, cool. So the next one that we've got, we have 2x minus 3. So what is that minus 3? Oh, excuse me, we have 2 to the negative x minus 3. There's a little bitty negative in there. I've overlooked it, but it's there. So we're going to do this in steps. So I want to start by doing our parent function. Can we do that? So if you want to use colors, if you have colors, that might be helpful. I'm just going to use dotted lines for all of our transformations here. So what's like our parent? What are we starting with, or what are we changing? Two to the x, right? Yeah. So I'm gonna like dot that in, and then 2 to the 4th, then 1/2, 1/4. So that's our parent function that we're talking about, right? When you make x's negative, what does that do to your graph? Flips it over which axis? Y. It's the one that you didn't make negative, right? So it's going to flip it this way. So now we're looking at a graph like this. So we'll still have our point here. We have it here, 1/2, 1/4, 2, 4.
Are you using different colors?
I'm not using different colors. I'm just doing dotted lines. So I can number it though. This is where we started. This was our second one once we flipped it.
Why so I have to flip it?
Because it's got a negative in front of that x in your exponent. And then the last thing that we have is -3. So how are we going to handle that?
Right 3, left 3.
Down 3.
I actually didn't know.
Okay, so we're going to go down 1, 2, 3. So I'm just shifting the key point, that 0, 1 point, and then everything else will follow. Does that make sense? So we have 1, 2, 3. Yep, that's what a -3 means. So I'm going to write our steps that we did up here. I guess my numbers are kind of off, but that's okay. So yeah, that all right? Questions? So again, is it like absolutely imperative that you know how to do this by hand?
Yes.
For this class, no. If you go on to calculus, yes. Then you'll be fine. Questions?
Can you go up a little bit?
Sorry.
What does that say down?
Down 3. Sorry, that's written very badly. I just put copy on my hand. It's fine. So if you start reading that next section down there, it starts talking about Euler. This chap named Euler. Just know that I didn't write that. I just copied this out of y'all's textbook. So it's a bunch of stuff that tells you how we get E. Y'all are y'all familiar with E? Guess so, maybe. Is that something that we've seen before? So, like, if you have y equals e to the x, it's on your calculator.
Yeah.
Maybe you've at least seen it there. So it's another function. It's like an exponential function. So it's like, I think, yeah, it's like 2.7 something. You have to know all that. Again, your calculator does it for you. So we're going to use basically just a regular exponential function to help us graph those. Does that make sense? Because that's all that e is. It's just a placeholder for some, it's kind of like pi. How pi is like 3.1415926, blah, 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 all that stuff, and we just put pi in place of it. So e is like that similar idea. So yeah, if we've got this function, we want to graph negative e to the x minus 3. So we're going to start by graphing e to the x. So basically, is it going to be growth or decay? We know that e is 2.7 something, so is that bigger than 1 or less than 1?
Bigger.
Bigger, so growth or decay? Growth, right? And what key point are your exponential functions always going to have?
1.
0, 1. So we can plot that point 0, 1, and we know it's going to be growth, so we can shoot up here and level out off to the left. Is that okay? If you wanted to get like another specific point, you could do e to the first power, which is going to be that 2.7 something, which would be up in here, so mine should probably be a little bit steeper, but that's enough for us right now. Is that okay? Yes, so maybe. Okay, so we've graphed our parent function here. Then we've got a negative outside, so is that going to reflect over the x or the y? the x, right? If your negative is just on the x to go over the y, it's on the outside, so we got to reflect over the x-axis this time. So we were up here, and we're going to flip it down here instead. So our graph is going to now look something like this. Is that okay? I'm going to write this off the side. That negative e to the x is y-axis, x-axis, x-axis. And then we've got a -3 in our exponent. So is that going to go up, down, left, right? What do we think? Well, let's see. So last time when we went down, it was a -3 not in your exponent. So if we have a -3 in your exponent, that's like with the x. So that'd be the same as like having it in parentheses, right?
Right.
So how's that going to change it? Right. 3. Yeah? So again, I'm going to put where we were, and then we'll draw where we're going to end up. So I'm going to take that key point and move it over 3. 1, 2, 3. And then everything else will follow.
Do you have to do like
What do you mean? I'm drawing where we started so that we can see how it moved. If you don't need that, then don't do it. So like on your homework when you have to graph these, if you don't need to do that, then don't worry about it. I think it's helpful just so you can like tell where everything's going, but if you can do all the reflections in like one step in your head, then go for it. Or the transformations. Questions on any of that? So again, is it absolutely necessary that you know how to do this without a calculator? As long as you got a general idea of what it's supposed to look like, as far as like, is it growth or is it decay, you'll be fine. So moving on to the next section, do we know how to solve exponential equations? No? Okay, cool. So we've got to learn how to do that real quick. So for this one, we've got 4, then 2 to the x is our exponent, and then we have 8 to the x. So we need to have the same bases for these so that the bases cancel out, and you can essentially just look at your exponents and solve the equation from there. Does that make any sense? So anytime you're doing exponential equations, you want to have the same bases. So I would jot that down, that you need the same bases. When I say bases, do we know what I mean? Like we need this 4 and this 8 to be the same number. So could we write 4 or 8 in a way to make it be 4? So like,
4 times 2.
but we were talking about exponents. So could we write like, is 4 squared going to give us 8? Can we rewrite it that way? No, so that's the only option with 4s, right? So let's try something smaller. So what about like 2s? 2 squared would give us what? 4. And then will 2 to the some power give you 8? 3. So you can write your base as 2, and then we'll just have to have those exponents that we needed to get to 4 and 8 as well. Does that make any sense? Do y'all kind of get what I'm saying with that? Yeah? So instead of writing 4, we're going to have 2 squared. Is that okay? And then that 4 had an exponent of 2x minus 1, so we're going to have to multiply by 2x minus 1. And that's because when you have a power to a power, you multiply. Those are like your exponent rules from Math 101. So then on the other side, how are we going to write 8 with a base of 2? 2 to the third power, so we'll have 2 cubed. And then it still had an x exponent, so we'll put 3x up there. Is that right? So once you have the same bases, you can essentially ignore the bases, set your exponents equal to each other, and solve like a regular equation. Is that okay? So let's go ahead and distribute on this side. So we'll have 4x minus 2 equals 3x. How are we going to get x by itself? You could subtract 4. I would subtract 3 and add 2, but that's just because I like to keep my exponents, or my x's positive. Anywho, when you end up doing all that, what do you end up getting for x? X equals 2. Questions on that? Are we okay? Yes, no, maybe? Anything we're not sure about, don't understand? Okay, so I think the trickiest part of these is just getting your bases to be the same. So once you get that down, you'll be all right. So looking at number 2, we already kind of have the same bases, right? Because we've got bases of e's. But we've got a bunch of stuff happening over here. So I think it's going to be easier if we go ahead and try to get this side as one term with one exponent. Does that make sense? So how could we rewrite e to the x squared? E to the what? When you have a power to a power, what do you do? Do we know exponent rules? Nope. Cool. So when you have a power to a power, you multiply. So when I'm teaching my math 1 kids that, I make them go, when you have a power to a power, you multiply. So if you need to do that, then you should do that to remember it. So power to a power, you multiply, so that's going to give you 2x there. Is that okay? Then how could you rewrite 1 over e cubed? How do we get stuff in the denominator? What kind of exponent moves stuff to the bottom? Negative. So could we not write this as e to the negative 3? Is that okay? So then from there, when you're multiplying terms with like bases, what do you do with your exponents? You do not plug it in. I don't know why we're on the calculators. Can we put those away? Because if y'all can't like do this without them, we just won't have calculators on the test. And that's fine with me, because you really don't need them. So what do we do when you have terms with like bases? You add your exponents, yes? So we're going to have e to the 2x minus 3 over there. And then we still have e to the negative x squared on the other side. Is that okay? What's that? Is that better? Okay. So from there, you've got like bases, and we just have one exponent on each side. So we can essentially just ignore the bases and set your exponents equal to each other. So you're going to have negative x squared equals 2x minus 3. And what should we do from there to solve?
Move it over the graph.
We should do what? Add the x squared over, so you're going to have 0 equals x squared plus 2x minus 3. And how do we solve that?
Graph.
No. Can you just do me a favor? Put your calculators on the floor right now. Everybody, calculators on the floor. Yeah, do not trust y'all, not use them. People have taught y'all bad habits to use things on there that you don't need to. Y'all are too smart to do like insolve and look at their... Just factor it. Factors of 3 that subtract to be 2 could not be easier. 3 and 1, right? Like that is so much easier than going in a calculator or doing insolve or whatever it is that y'all do. So plus 3 and minus 1. Is that okay? So then once you factor it, what do you do? How do you find your roots? Set into 0 and solve. And you essentially are just changing your sign, so we're going to get x equals negative 3 and x equals positive 1. And those are our answers there. Questions? This is really out of focus. We all right? Anything we're not sure about, don't understand? Okay, so that's exponential functions. So this next chunk is all going to be about log functions. So y'all should have seen these in Math 3, so it shouldn't be like brand spanking new, but it probably is. So it's the inverse of an exponential function. So it's just a different way to write things like an exponent. So some people say it like around the world. Does that ring any bells with y'all? Duncan said around the world. So basically you can just take this guy here is going to be your exponent and it's going to equal this number. So that's what they did here. That's how logs work. So we're going to do that with these. So you're going to rewrite these log statements as an exponential statement. Can I zoom back out? Is that okay? I can't see everything I need to here. Alright. Zoom, it's not really zoom, just adjusting. So for the first one over here, we're going to take a to the 5th power. And and say that it equals 4. That arrow is really ugly. So that's how you would change something from logs to like exponents. Does that make sense? So that's the around the world thing. People call it that sometimes. So then for number 2, you're going to have e to the what? So e to the negative 3 equals b. Is that okay? Questions? All right, so then for number 3, how are you going to write that one? 3 to the c equals 5. Is that all right? That's all you got to do as far as like switching back and forth. Is that okay? All right, so then for the next part down here, we want to change it from an exponential expression to a log expression. So how are we going to go backwards? You can basically still just go the same way, y'all. So we can say, same way? No, counterclockwise, you're right. So, you're going to have your log, and then, do we know how to read logs? So it's like log base a of x is how you read that. So when they say base, whatever your base is for your exponent, that goes down in the bottom. Does that make any sense? So like some people say like base is in the basement. I just think that they're both base, so that helps me remember that. So it's log base 1.2 of m equals 3, because it's got to equal your exponent. Is that all right? Did I do that backwards? No, that's correct. Is that okay? Yes, no, maybe? Yeah? All right. So then for the next one, how would we write that one? Log base what? E of 9 equals b. Is that okay? Do we know what log base e is? Okay, that's all right. We're going to get there in a second. So then for number 6, how are we going to write that one? Oh, I'm writing the wrong thing. Log base a of 24 equals 4. Is that all right? Questions? Okie dokie. So for the next part, we're going to evaluate these. So if you had a calculator, you could type it straight in, but y'all lost your calculator privileges, so we've got to do it the old-fashioned way. So log base 2 of what is, or log base 2 of 16. So you're thinking 2 to what power gives you 16? So that one's 4. You don't need a calculator for that, yeah? Is that okay? Questions there? All right, so looking at number 8, we've got log base 3 of 1 over 27. So anytime you have a fraction here, what is your answer probably going to be? Negative. Negative, because your exponent had to put it to the bottom and make it negative, right? So 3 to what power gives you 27?
Negative 3.
3. Does that make sense? Have we done that much before with logs?
Yes.
Yeah, that's all we did? Cool. Fantastic. Some of us didn't even get that, so that's okay. All right, so for the next section, we want to find the domain of these log functions. So if you're doing a log, you've got to make sure that inside this guy is greater than 0, because you can't put negative numbers in there, okay? So when we go solving stuff later, that's going to be like a restriction, but we're not there yet. So basically, you're just going to take whatever is inside your log and set it greater than 0. So do y'all remember doing that a long time ago with like square root functions? When we were doing domain and stuff, like back in this second unit, first or second unit? That was a long time ago, but it's coming back. So solve for x, what do we get? Negative 3, so that's your domain. Do y'all remember how to write it in interval notation? How do we do that? Negative 3 times 1. Is that okay? Questions? All right, cool. Same thing for number 10. So for that one, it's going to be a little bit trickier because we've got a rational function inside there. So we've got to make sure that that whole thing is positive. So we're going to evaluate the numerator and the denominator separately and see where it's going to be positive. So we know that 1 plus x over 1 minus x has got to be greater than 0. So the easiest way to do this, I think, is to make like a sign line. I don't know if y'all have done that before. Maybe should have done that in Math 3. So what are values that are going to make your numerator be 0? -1. What are values that are going to make your denominator be 0? +1. So you put those zeros on your sign line. So then we're going to have for 1 plus x, we'll put our signs down here, and then 1 minus x, we'll put our signs below it. So if we put a negative number in up here, so pick a negative number, any negative number. -4, pick a number between -1 and 1. 0, and pick a number that's bigger than 1. Or you can pick any numbers you want that fall in those intervals, yeah? So then you put those test values in and see what sign you get. So if we plug in a -4 to your numerator, what's 1 plus -4? So it comes out negative. Is that okay? All we care about is the sign. Is it coming out positive or negative? So if we plug in a 0, 1 plus 0 is going to give you a positive number. Is that okay? If we plug in a 4, 1 plus 4, is that going to give you positive or negative? Positive. Is that okay? Have we done this before?
No.
Okay. So then we're going to do the same thing, but we're doing 1 minus x this time. So if we plug in a -4, 1 minus -4, is that going to come out positive or negative? Positive, because you end up adding, right? If we plug in 0, do you come out positive or negative? If we plug in 4, 1 minus 4, is that going to give you positive or negative? Is that okay? So if we have negative over positive, is our final fraction going to be positive or negative? Negative. If we have positive over positive, will our final fraction be positive or negative? Positive, so that's probably what we want. And if we have positive over negative, that's still going to come out negative too. Does that make sense? Because we're looking back to our rational function we had over here. So the interval where we were positive was from where to where? -1 to 1, that's your domain. Is that okay? If there was more than one interval there, so like let's suppose that we had bigger functions going on here and we had a bunch of zeros to put on that sign line, you would just write all the intervals. Do you remember how to join intervals in set notation or interval notation? The U. Good. Are we okay? Questions? All right. So now we're going to graph some. So the way that we do graph log functions, you have to use exponential functions. Yeah, you kind of use exponential functions to get you there. So we're going to take your log function, and step 1, we're going to rewrite it in exponential form. So like we were doing over here. Okay, so we're going to do that around the world thing. And then because a log function is the inverse of exponential functions, we're going to take the inverse of what you have from there. And then we're going to graph that and then reflect it over that y equals x line, because that's how inverses work. So that's how all this is going through, and we're just going to do one because I think that's the best way to understand it. Okay? All right. So first thing we need to do is rewrite this in exponential form. So that's what step 1 is up here. Write it in its equivalent exponential form. So how would we do that? I'm going to move it, it says equal y over here, because we've been going around the world this way. So we would say what? 2 to the what? Y equals x. Is that okay? So we write that in exponential form. We good with that? Yes, no, maybe? All right. So then we're going to do the inverse. Y'all remember how to do inverses? So it says find the inverse, x is y and y is x. So what should we do? Switch x and y. So instead of 2 to the y, we're going to have 2 to the x equals y. So that's how you find inverses. We did that a long time ago. right? You switch x and y and then solve for y. We're already solved for y, so we don't have any solving to do. Is that okay? So then from there, we're going to graph the log function's inverse, this one. So let's get some points for that, which we graphed this earlier. That was the first graph that we did, right? So we already know that it's going to be growth, and if you look back on the front, that's where we're getting at, right? 2 to the x. We've already done that today, so really shouldn't be much to get this there. So I'm going to draw the table just in case, because you won't always have a graph that you've already done. So we need x's and y's. We'll just plug in 3 points. So let's go -1, 0, and +1. So when we plug in 0, what do you get? Anything to the 0 power gives you what? 1 every single time. 2 to the first power gives you what? 2. And 2 to the -1 gives you what? 1/2. Is that all right? Yes, no, maybe? So where was our asymptote happening for those? Do you remember? So let's look back at the graph that we already did. We said that right here when it's getting super, super close to 0, that was our asymptote, right? So it was at 0. Is it y = 0 or x = 0? Y, because it's horizontal. Does that make sense? So we're going to jot that down as well, because it's going to be helpful for our graph later. So your asymptote, ASYNP, is at y = 0. So then we're going to do the inverse of all that. So when we switch it, we're still going to have x's and y's. How is our table going to be different? You just flip x's and y's, right? That's how you do an inverse. You switch your x's and y's. So our x values are now going to be 1/2, 1, and 2. And our y values are now -1, 0, and 1. And our function that we're doing now is what we started with, because when you do the inverse of, or not inverse, yeah, inverse of that, so switch x and y and solve, this is what you end up with, y = log base 2 of x. So when we inverse, this is where we end up. So let's sketch in this one first. And I'm just going to do it as a dotted line, so if you're using colors, you may want to use colors there, totally up to you. So we're going to have 0, 1 as a point, -1 and 1/2, and then 1, 2. So then it tells us to reflect it over y = x. So what does that line look like? Y = x. It's just that diagonal, right? So it goes straight through the middle. So I'm going to put that as a dotted line as well, because it's not actually on our graph. And we're going to reflect it over that, which we've got some points to help us get there. So at 1/2 we had -1. At 1 we have 0. At 2 we have +1. So there's our graph. And where do you think the asymptote is happening this time? Instead of y = 0, because that would be right here, what would it be instead? X = 0, because it's vertical now, yeah? It also wants us to find the domain and range. So what would your domain be for this graph? What's the smallest x value we could possibly have? Or what's it getting super, super close to and never going to touch? 0. And then it goes to where? Infinity. And what about our range there? Negative infinity to negative infinity, or you can just put all reals, however you want to do it, it's fine. And that's it. Is that okay? Questions? Huh? So logs are inverses of exponentials. So if we can start, we know how to graph this, but we don't know how to make a table for that. Does that make sense? So that's why we're going to start here and then flip it. Yeah. Kind of. Right. So it goes back and forth. Yeah. So are we okay to try another one? Yeah, so let's do that. Cool. So we've got y equals log base 1/3 of x. So I'm going to move the y over here just so it's a little bit easier to see that going around the world. So when we write this in exponential form, what are we going to get? 1/3 to the what? Y equals x. So then when you take the inverse, switch your x and y. So we're now going to have 1/3 x equals y. Is that all right? Okay, so we need to make a table of values for this so we can start graphing it. So we're going to have x and y. And again, we'll just do like 3 points because I think that's enough. So we can do -1, 0, and 1 again. Those are generally going to be the easiest, so I would use those. This is y equals 1/3 to the x. So when we plug in 0, what do we get? 1. When you plug in 1, what do you get? 1/3. When you plug in -1, what does that negative do? Flips it, so we just get 3. Okay? Questions? Alright, so that's y equals 1/3 x. So then if we do the inverse of this guy, we're just going to switch the x and the y's in our table. So our y values are now what? These values are now here. Sorry, I meant those going here, but you were correct. Our y values are going to be those x values. We were just going backwards. 1/3, 1 and 3, and then 1/3 gave us 1, 1 was 0, and -1 here. I just went like from smallest to greatest because that's how tables work. If you don't want to do that, you don't have to. That just makes sense to me though. So we'll start by graphing this one. And I'm going to do that with the dotted line. So at -1, we have the 0.3, 1, 2, 3. At 0, we have 1, and at 1, we have 1/3. So where's that asymptote happening this time? Still at y equals 0. So where will your asymptote be for the inverse? X equals 0. So we'll plot these points. So at 1/3 we have 1. At 1 we have 0, and at 3 we have -1. So if you wanted to sketch in that XY line and flip it over that, you can. I think it's just easier to plot the points since you get them from the table. But whatever you want to do is fine. So we'll graph that, and that'll be our function. Mine's a little gross, but that's okay. Questions? Anything we're not sure about there, don't understand? So the last part we want to do is our domain and range. So what would your domain be for this one? Domain is x's. 0 to infinity. What would your range be? All reals, so negative infinity, positive infinity. Do what? Yes, if you have, well, if there's other stuff happening besides just x. So like the next one. Yeah. Kind of. You'll just have to look at the graph. If it's been shifted any direction, then it would change. So that's how we graph the log functions. So the last part we're talking about your natural log and common log. Have we heard of natural log before? So natural log is ln, and that is what log base e is. So if you have log base e, it is natural log. So log base e of x is natural log of x. So when you see that, it's the same thing. And then if you just see a log without a number written in the base, it's log of 10. So if you're doing like log 10 of x, it's the same thing as just log of x. Feeling here? I do. Can I finish next real quick and I'll send him? Like maybe 10 minutes, probably not that long. Okay. Right. That okay? Are we good with those two things? Okay, cool. So, blah, 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 all that. So we're going to graph, determine the domain and range, vertical asymptote, identify the inverse, and the domain and range of the inverse here. So, the first thing that we're going to do is graph the parent. So, like the ones that we did before where we did all the transformations, we're going to start there. So, we're just going to graph natural log of x first. So that graph, I'm just going to tell you what it is. So, yep, natural log of x. So you're going to have a point here, and it goes down this way. This should be dotted. Make this dotted, and this way. So that's your natural log of x. So I'm going to put a 1 beside of that because that's our parent function. It just is. Is that right? Because if we went and did that like we did all the other ones, that's log base e to the x, right? So you would do the around the world thing, and e is 2.7 something, blah, blah, blah. So it gets really messy. But where we did this one, so imagine instead of having a 2 here, you have that 2.7, blah, blah, blah. So you're still going to get the same graph. Does that make sense? So you could go through all that, or you're going to end up in the same place. Is that okay? All right, cool. So, that's your parent function. So then it has a negative out front. So what is that going to do? Flip it over the x-axis. Or if it's, yes. I wrote it backwards every single time in my notes. I did it correctly and just wrote it wrong. It's fine. So we're going to flip that guy, so we're going to look like this instead. And I'm going to put a 2 beside that one because that's the second thing we did. So the last thing that we have to deal with that is that minus 2 inside parentheses. So what's that going to do? It's going to shift it to the right 2. So I would just take your key point and then go over 2. So 1, 2. Is that all right? Are we okay with getting the graph? Yes, no, maybe. Alright, so I'll put a 3 beside that one, so that's our final graph then. So then we need to find the domain and the range and the vertical asymptote. So for your domain, do y'all remember where we were finding those earlier and we said whatever is inside your log has got to be greater than 0? So you could do it that way and set this, say x minus 2 has got to be greater than 0. Or you could just look at your graph and we know that it's going to level out at 2 there from that asymptote. So either way is fine. I'm going to do it algebraically first. So we're going to say x minus 2 has got to be greater than 0. So x has got to be greater than 2. So your domain is going to be from 2 to infinity. What's your range going to be? All real, so negative infinity to positive infinity. And then our vertical asymptote, that minus 2 shifts everything right 2. So instead of it being at x equals 0, it's going to be at x equals what? 2. The last thing it wants us to do is just identify the inverse in the domain and range of the inverse. So what would the inverse, are we going to do that? We're not going to do that. Never mind. We're just going to skip that part. Questions? Okay, cool. So we're going to go and solve log equations. So these are easy because there's not logs on both sides, so you can just do around the world and set it up from there. So we can say 3 squared equals what? 4x minus 7. Is that okay? So what is 3 squared? 9 equals 4x minus 7. How do you solve for x? Add 7, so we're going to have 16 equals 4x. And what do we get for x? 4. And we're all done. Is that okay? So you just need to make sure when we plug that x back in that we don't get a negative number inside your parentheses here. So if we have 4 times 4, what do you get? And 16 minus 7. 9, and 9 is not negative, so we're okay there. And that's a way to check your answer as well. That's going to be more of a factor later when we have like logs on both sides and you're going to have quadratic functions, so you get 2 answers and sometimes you have to throw one out. So yeah. For number 2, how could we write this? X squared equals 64. So what does x equal? 8. Why is it not positive or negative 8? You're not going to have a negative in this little base. Is that okay? Questions? Alright, so for equations today, this is all you need to know. And they're easier, we'll do harder ones on Monday. So for number 3, it says using logarithms to solve. So you can rewrite this as a logarithm and then solve from there. So kind of like we were doing in that section right here, where we take the exponential and rewrite it with a log. So we would have log base what? E of what? Equals 2x. Is that okay? And we said that log base E is what? Natural log, so ln. So we can write this as natural log of 5 equals 2x. And then what do we do to get x by itself? Divide by 2. So we've got natural log of 5 all over 2 equals x. You can type that in your calculator to get a decimal. You get x equals 0.805. And that would be your answer there. Questions? I'm sorry? I should not have written both. One or the other. It's an approximation. It's rounds. So you can do the squiggle or just the equal. It doesn't matter. Anything else? Are we okay? All right.